me. Hi, sorry. I'm Keisha. I don't know if I'm supposed to be here.
What course
This-
are you
Let me see. Math 125.
Section 160?
Okay.
So you're going to 12?
Yeah.
Yes. Good afternoon. Starting actual calculations now. So we're continuing with descriptive statistics. So last time we just kind of looked at some basic definitions, just an introduction. And we saw that there are two branches. There's descriptive statistics and inferential statistics. For descriptive statistics, generally speaking, there are three broad types of measures: center, spread, and position. Today we go over measures of center. There are three that we look at: the mean, or the average; I really wouldn't list center of gravity there. Center of gravity is more of a weighted average than just a straight up average. All right, so there's a lot of types of means. There's the arithmetic mean, which is generally what we think of. And it's the sum of all the values divided by however many there are. There's also geometric mean, which we're not going to go over, I don't believe. And then there's a weighted mean, which we also look at. Median is the data point that cuts it in half, so to speak. In other words, it's the point where half your data is less than it, half your data is larger than it. And then there is the mode, which is just the value that occurs most often. The mean is affected by extreme values, or known as outliers. This makes it non-resistant. Now, let's say we have quiz scores and they're all, for the most part, between 80 and 100. Right? So we all get B's and A's. You calculate the average. Now I throw in a quiz score that's a 20. That's really going to drastically affect the average. Right? So it's not resistant in that sense. Now remember, two types of categories we look at: population and sample. Right? So we have a parameter and a statistic. They are represented differently, but essentially found the same way. Population mean is represented by the Greek letter lowercase mu. Sample mean is represented by X bar. Right. But they're found the same way. Sum up all the values, divide by the total number there are. Again, different ways of representing sizes. For a population, it's a capital N. For a sample, it's a lowercase n. Right, that E symbol, this one right here, that's actually a capital sigma. And in mathematics, that is the symbol for summation. So that's sum of all x. Add up your data values. Median, again, it's the value that cuts your set in half. To find the median, you first need to order your data set. It needs to be in ascending order. The median is resistant. It is not drastically affected by extreme values. What really affects it is the number of data points you have. So something you should have learned in elementary. When you deal with integers, there's always two possibilities for an integer. It's either even or odd, right? Well, the number of data points you have is an integer, isn't it? You can't have half a data point, right? Well, that means that we either are going to have an odd number of points or an even number of points, which dictates how we find the median. If it's odd, it is just a data point that's directly in the middle. If it's even, then you find the average of the middle two data points. Right, so generally speaking, say you have an odd number of data points. Take the number of data points you have, minus 1 divided by 2. That's the position of the median. And so you have 51, data point number 20, no, I did that wrong, plus 1. Data point 26 would be the half, would be the median. Right, there's 25 less than it and 25 larger than it. If it's even, say 52, half of 52, 26. Should be data points 25 and 26 would be your two centers. You add those together, divide by 2. Right, that should give you 24 on each side of those two. You can compare mean and median to determine what's known as the shape of your data set, shape of the distribution. If the mean is larger than the median, it's called right skewed, or skewed to the right. If the mean is less than the median, it's skewed to the left. And if the mean is the median, it is symmetric. Realistically speaking, if it's a true random sample, you're not going to have symmetry. Right? If your data set is actually perfectly symmetric, where the mean and the median is the same, it's not really a true collected data set. Right? The odds of that happening are so small, it's negligible. If it was randomly selected. Right? Obviously, we can choose data where the mean and the median are the same. Right, and then graphical representations. This is what it would look like if it was left skewed, something similar to this. Right skewed, symmetric. The bell curve, they call it. Finally, the mode. It's just the value that appears most frequently. There's no calculations for that. You just count how many times each data point occurs. The one that occurs the most is your mode. If there are two more values that occur the same number of times than it is the highest, then it's multi-mode. You have more than one mode. The one exception to that is if every data point occurs only once, then there is no mode. Or if they all have the same frequency, so they all occur the same number of times, there'd be no mode. Mean and median only makes sense for quantitative data. And if you have, let's go with hair color. And I just collect hair color of all students. Would it make sense to say, what's the average hair color? And that doesn't really make any sense. Same thing with median. It really wouldn't make sense to say what's the median hair color, because you can't really list it in ascending order. You could list it alphabetically, but that's not the same as ascending. Mode is for both types of data. Right? I can say what's the most common hair color. That's the mode. Keep in mind that also holds if your qualitative data is used with numbers, ordinal, right? Like the Likert scale. You could theoretically find the average rating, but it really doesn't have any mathematical meaning. For small data sets, finding mean, median, mode by hand is fairly simple. For much larger data sets, it becomes more cumbersome. So I do have examples, both where we're going to do it by hand, and I'll show you how to do it in Excel. Right, so 3 measures. Start with the mean. They don't specify if this is a sample or population, so I'm just going to assume sample. X bar. Sum of the values divided by n, divided by the total number. You have 9 data points. So you just have to find that sum. Should sum out to 203. And so it'll be 203 divided by 9. They're both divisible by 3. No, I'm sorry. 2 and 3 is 6, it's not, it's 5. Because that can't be simplified. So that would be your exact average value, your exact mean. 203 over 9. Or if you want to approximate it, 22.556. It's actually 22.5 repeating. Median, 9 data points. Is 9 even or odd? It's odd. 9 plus 1 is 10, divided by 2 is 5. Fifth data point is your median, so 24. Mode is just which one occurs most frequently. 24 occurs 3 times. 18 occurs twice, everything else only occurs once. So the mode also happens to be 24. And you can look at this data set. Median is larger, so it is right skewed, but it is a very slight right skewed. It's almost symmetric, almost perfectly symmetric. Mean sum of the data points. divided by the total number of values you have. There's 8 of them. Should give you 75 when you sum them up. That does not simplify. However, it does have an exact decimal value. 9.375. And generally speaking, not measures any power of 2, it's going to have an exact decimal representation. Any power of 5 will have an exact decimal representation, powers of 10. Median. Well, this time we have 8 data points. Even or odd?
Even.
It's definitely even. So we need the middle 2 values, 9 and 10. You just calculate their average. Mode. This is bimodal. It has 2 of them. Sorry, not 10. 12. Both occur twice. Again, this is very slightly skewed to the right, but this is ever so slightly. In most practical senses, we would say this is symmetric, and we would treat it as such. So determine shape. Right skewed, left skewed, or symmetric, which means we need 2 values. We need its mean and we need its median to compare, right? Mean 55 over 6. .167, just about. Median. Should be the average of 5 and 6, right? Just 5.5. So what's the shape?
Right skew.
So these two would actually then be left skewed. Median larger is left. Take out 30. And you can just look at that and see that 30 is kind of an oddball. So if we take out 30 and do the same thing, well, 55 minus 30 is 25. 25 over 5 is 5. Median, we now have an odd number of values, right? Oh, look, the median is 5. So notice that while, yes, the median did technically change, it didn't really change by much, did it? With that extreme value added in, that 30. But the mean did. And now that would be symmetric. Perfectly symmetric, in fact. Sum those values up, you should get 80. Mean would be 80 over 9, or about 8.889. Median. Is what? It's just 10, right? So that's larger, isn't it? Larger than the mean. Left speed. So here's data set. Could be colors of marbles. Measures of center. Does an average make sense? All right. Mean color makes no sense whatsoever. So there is no mean. Median also doesn't make sense. This data set's only going to have one measure of center. Which color occurs most frequently? That would be your mode. So start with that data set. 10, 12, 14, 15, 17, 21, 22, 23. Calculate its mean. Sum of your values over how many points are there? What do you get? What did you get for the numerator? What was the sum of the data?
134.
16.75 is the mean. And what is the median?
60.
How'd you get it?
And the two middle numbers divided by
Which are what?
15, 17.
Now throw in the data point 100 and do the same thing. The mean shouldn't be that difficult. You just add 100 to the numerator and add 1 to the denominator, right? 234 over 9.
26.
What does the median become now?
17.
Again, just to point out the drastic change. Median didn't change that much, but the mean did. Data set. We have some data set. Mean is 32.4. The median is 29. Every value in the data set is increased by 5. We want the new mean and the new median. Show this. Perfect. Number of data points doesn't change, right? Using properties of summations, that just becomes two sums. Right, sum up all your data points, and then you just sum up 5, however many data points there are. But there are n data points, so 5 gets added to itself n times, which is just 5n. It's two separate fractions. Sum of x over n plus 5n over n, which is just 5. Old mean plus 5. So if you add 5 to every data point, it's just adding 5 to the mean. Median. But now explain it. You have two possibilities. If n is odd, the middle value was 29, you're just adding 5 to its 34. That's pretty simple. If n is even, then 29 is the average of your two middle values. Oh, but both those middle values get increased by 5. Then using the same argument as with mean, that's also going to increase by 5. So in either scenario, the median will just increase by 5 as well. Data set mean of 8.2, median of 7. Every value is now doubled. New mean and median. So this time I'll just do it this way. Again, you're not changing the number of data points you have, right? You're just changing each value. So the mean will be the sum of 2x divided by n. Distribution property. Remember, that's a sum. Factor out 2. Written another way, two times sum of x over n, but isn't sum of x over n the original mean? So your new mean is just twice it, 16.4. Median, you use the exact same argument as before. If n is odd, then the median 7 is already a middle value and it gets doubled to 14. If n is even, your median is the average of the two middle values. Each of those values get doubled, so you're doubling the average, the old average, still 14. So the median also doubles. For the commuters randomly selected, asked what their commute time is. The responses are shown. Determine the measures of center. So if you wanted to, you could try and do that by hand. 40 is still a relatively small sample. We input all our data into Excel. All right, we'll just pretend that you sat there and you already entered the data. First, for the mean. Equals. Command is average. Then you need to enter your numbers. So 2 ways you can do that in Excel. First, is just click and drag. Those out the parentheses. But if you notice, it automatically types it in the other way for you. A1 colon A40, so you can also just type in what your cells are. So cell A1 up through cell 40. Enter, there's your average. Mean is 31.45. For the median, it's just median command. And then same thing. Oops. A40. Then you just enter the cells that your data is collected in. Median is 26.5. Mode. So 3 of them, you can't see it because of how I have screen share set. But when you start typing in, it's going to give you a list of functions. There are 3 that are showing. Just straight up mode, which is outdated. So it's recommended you do not use that one. Then you have .mult and .sngl. You want singular. We just have a single column. Notice one. Excel makes things so much easier. Random student, this one's quite useful. Random student selected from an elementary stats course. Table below shows categories, score in each category, and the weights of each category. And we want to determine the final grade. This is a weighted average. Doing it by hand is fairly straightforward. You take the sum of each score times its weight. So it'd be 92 times 0.15, 88 times 0.2, so on and so forth, add them all together, and then divide by the total weight, which in this case is 1.9. Doing it on Excel, again, I've already created, I should have zoomed in for all the sheets, that would have been nice. All right, we entered the data already. Let's this final grade. That's kind of what we want to do. We want to take the product of the scored and weights and add them together. That function is sum product. We need 2 entries. What is the first value of the product? Your score, right? So that's B2 to B6, comma, the next one. And if there is more that you wanted to do, you can keep going. Now divided by the total weight. Sum C2 to C6. $90.1 is the weighted average. And then this one is just, no, you can't see that yet. The next one is asking to repeat what we did before, right? We had the mean, we added 5. Find new mean and median. Double, find new mean and median. Now we're just going to verify it with that larger data set to see if it's as we expect. So what I'm going to do is I have that already there, but I think I'm just going to come back to what I had originally, just so we can more easily compare. So let me do this as mean plus 5. I'm going to create a new column, A1 plus 5. And I don't have to do that for every column, because if you notice how the cursor changes, bottom right. Once it changes, just click and drag. It'll now apply that formula to every single cell. Oh look, that was J, right? So now it's just the same thing. Average J1 to J40. So we'd expect it just to add 5 to the mean, right? So we'd expect what, 36.45? $36.45. Right, expect what, 31.5 for the new median? 31.5. Didn't answer, but let's also do the same thing for the mode. So what do you think is going to happen? What do you think this new node is going to be? And the argument's exactly the same, right? If 20 was the most occurring value before, you just add 5 to every value, that 25 should be the most occurring. Let's now go mean times 2, right? So double all the values. New column, going to call it L, will be A1 times 2. We're going to do the same thing to apply to all of the cells. That was now L1, or that was column L, so L1 to L40. We would expect the mean to double, right? So it's twice that, 62.9. You'd expect the median to double. 53, it should be. 53. And you would expect the mode to double as well with the same argument, right? And it does 40. Good. Questions on measures of center? First group assignment is up. Is the not showing? Oh, yeah, that's why it's not showing, because I'm not actually in a group, so it won't show for me. That's nice. That's actually annoying. I'll worry about that later. So in the assignment, you're going to see 4 items. First one is the CSV file you're going to need that has the data set that you're going to be using. Details is the actual assignment itself, what I expect you to do. The third is the grading rubric. That's obviously how you're going to be graded. And then the drop box. This is just where you'll upload the assignment when you're done. It is not due until October 14th, before class starts. But it might be a good idea to get started on it. Remember, this is a group assignment. The groups that you formed are the groups you're working with. I already have those groups set up on Blackboard, so you should be able to see it. You should be able to see the groups. Because I'm not actually in a group, it's a student preview. If you click groups, it should show you your group. What I want to do for the rest of class, because again, there's been quite a few roster changes. We have 18 minutes left. Get into your groups. because I do have a worksheet. Again, this is just for your practice. I'll post the solutions. If you don't have a group, all you need to do is look for a group with less than 5 members and try and join it. And then, before you leave, if your group has a new member, you need to see me so I can actually add you to that group. Right? Otherwise, you're not going to be able to see the Dropbox. So go ahead.